Okay, today we're going to look at some problems from section 2.1 titled Tangent Lines and Rates of Change. Specifically what we're going to do is we're going to look to find equations of tangent lines, of normal lines, and then we're going to talk about something called the derivative. Okay, so the first question is find the equation of the tangent line and the normal line to the graph of g of t equals t squared minus 3t at t equals 4. Okay, so in order to find the equation of any line, we need two things. We need a point and we need the slope. Well, the point, we're told that t is 4, and then we have to find f of 4. So 4 times 4 is 16, minus 3 times 4 is 12, 16 minus 12 is 4. So the coordinate is 4, 4. And the slope we find by taking, and we're finding the slope at 4 here, the limit as delta x approaches 0 of f of 4 plus delta x minus f of 4 all over delta x. And in general, what we learned was that the slope at x1, any x value, is the limit as delta x approaches 0 of f of x1 plus delta x minus f of x1 all over delta x. Okay, so finding specifically the slope of the tangent line here, we'd have the limit as delta x approaches 0. So here's my function. So specifically, I should have used g here because our function is named g, but obviously it doesn't matter how we name it. And I guess similarly here, there should have been a g of 4. Okay, so g of 4 plus delta x means I'm going to plug 4 plus delta, and another little mistake here, right? We should have had a t just to be consistent with our variables. And again, the independent variable we can pick to be any variable we would like. Okay, so g of 4 plus delta t, and I'm going to use parentheses here. We have 4 plus delta t squared minus 3 times 4 plus delta t. Okay, so there's substituting 4 plus delta t for t here, minus g of 4. So that would be 4 squared minus 3 times 4 all over delta t. Okay, so the truth is that if we were to apply our limit laws at this point, right, we'd have 4 squared minus 3 times 4 minus a 4 squared minus 3 times 4. That would be 0. The denominator would be 0. So right now we get 0 over 0, which we know is indeterminate. So we know that we need to do some manipulation here, some algebraic manipulation. So we'll expand all of this and see what we see. Okay, so we're going to have a 16 plus an 8 delta t plus a delta t squared minus 3 times 4, 12, minus 3 delta t. And here we have 16 minus 12 all over delta t. All right, so I have 16 minus 12, which is 4, minus a 16 minus 12, which is 4. So that all equals 0. And now notice I have a 8 delta t minus 3 delta t. So I'm going to simplify that to 5 delta t plus delta t squared all over delta t. So we still have 0 over 0, but notice I have a delta t in both terms in the numerator, so I'm going to factor the delta t out. That leaves me with 5 plus delta t over delta t. The delta t's divide out, right? That equals 1. And so we have the limit as delta t approaches 0 of 5, plus the limit as delta t approaches 0 of delta t. Well, that's going to be 0, that's 5. So the slope of the tangent line at 4 is equal to 5. Okay, so for our equation of a tangent line, I'm going to use point slope form. And my point is 4, 4. My slope is 5. So we have y minus 4 equals 5 times x minus 4. So there is our tangent line. And for the normal line, remember the normal line will be a line perpendicular to the tangent line, which means it's also perpendicular to the curve, the graph at 4, and the slope will be the negative or opposite reciprocal. So we'd have y minus 4 equals negative 1/5 x minus 4, and there is our normal line. Okay, so let's look at another problem where here the directions are just to find the derivative of h of x equals the square root of x plus 1 using the limit process. So the derivative means that we're going to find a function that we could then substitute in any x value to find the slopes of tangent lines at those particular x values. So the derivative, again, we're going to call the derivative here h prime of x, because we have h of x, and that will be the limit as delta x approaches 0 of h. So over here, right, we have h plus delta x, and that would be x plus delta x plus 1. Then I'll write it out here. Minus h of x over delta x. Okay, so we have the limit as delta x approaches 0. We've already established what our h plus delta x is. X plus delta x plus 1 minus now h of x, which is the square root of x plus 1. All of that over delta x. Similar to the last time, if we were to apply our limit laws, we would end up with 0 over 0, which tells us it's indeterminate. And our strategy here generally is to rationalize the numerator by multiplying by the conjugate. So we have x plus delta x plus 1. Let me move that 0 over 0 out here a little bit more. Plus the square root of x plus 1. And then we would have the exact same thing in the numerator or denominator. Now remember, one of the things that we've talked about is when we have 0 over 0, not only is that indeterminate, but that means there's a factor in common between the numerator and denominator. And what we're trying to do is extract that factor. So in the denominator, we're not going to distribute. So the numerator, right, that'll give us x plus delta x plus 1. And then here we have the positive product, the negative product. So that would add up to 0. And then minus, when we multiply those, we're just left with x plus 1. And then in the denominator, delta x. But then we have that rest of that expression, x plus delta x plus 1 plus the square root of x plus 1. Okay, looking at our numerator to simplify, I have an x minus x, that's 0. And a 1 minus 1, that's also 0. So we're just left with a delta x. So we have the limit as delta x approaches 0. And the denominator, so there you see the delta x in common. There's our factor in common. So that divides out. And we're left with the limit as delta x approaches 0 of 1. Divided by x plus delta x plus 1 plus the square root of x plus 1. Excuse me. So no longer do we have 0 over 0. Applying our limit laws, the only delta x we have here, that would go to 0. So that would leave us with 1 over the square root of x plus 1 plus the square root of x plus 1. And finally, I'll bring down my h prime of x. This limit would equal 1 over 2, because we have 2 of those, x plus 1, which is our derivative. So one of the things I can do from here, if I wanted to find out the slope of the tangent line at 3, I could plug in 3, say h prime of 3, I'd get 3 plus 1 is 4, square root of 4 is 2, and so the slope of the tangent line there at 3 would be 1/4. And a lot of things we can do once we have the derivative. Okay, one last problem from section 3.1. The question reads, let me focus that a little more. Find the equation of the line tangent to the graph of f of x equals x cubed and parallel to this line. Okay, so here we're not giving you an x value, but basically what you're told is that the tangent line to this curve has to be parallel to this line. And we know that lines that are parallel have the same slope. So if I solve this equation for y, I know the slope is 3. So the slope of the tangent line, which we know is the derivative, that has to be equal to 3. And then I can solve for x. So I'm going to find the derivative by, again, taking the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So here is my limit. So now I have x plus delta x cubed. There's my f of x plus delta x minus f of x, which is x cubed over delta x. Again, we have 0 over 0 indeterminate. So I'm going to expand the numerator and see how that, or what that leaves me with. So using my binomial expansion in Pascal's triangle, I know I have x cubed plus a 3x squared delta x plus a 3x delta x squared plus a delta x cubed. So that is this binomial expanded minus x cubed all over delta x. So I see I have an x cubed minus an x cubed. So that leaves us with, and I notice that I have a delta x in every term, so I'm going to factor that out now. And that leaves me with the 3x squared plus a 3x delta x plus a delta x squared all over delta x. The delta x divides out. We're left with the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared. Now applying our limit laws, both of those terms go to 0. So f prime of x, our derivative, is 3x squared. And so again, back to the original question, finding the equation of the line tangent to the graph and parallel. So we know the slope is 3, and we know that the derivative f prime also represents the slope. So both of these are equivalent. They're both slopes. So I take the slope of the tangent line equal to the line parallel. I get 1, square root both sides, absolute value of x, remember that from our AS Algebra 2 days. So we get plus or minus 1. So it looks like there's actually 2 places, and if I just draw a quick sketch here, right, there's our x cubed graph. The line 3x plus 1 would look something like that. So it looks like there are 2 places on the curve where at 1 and negative 1, so if we call that 1, or negative 1 rather, and that 1, where we end up with lines that are parallel to this line and tangent to that graph. Okay, so again, we know the slope is 3, and we have 2 different x values. So f of 1, right, is 1 cubed. So that point up here is 1, 1. So I know that one tangent line, y minus 1 equals 3 times x minus 1. And then over here, I'll do f of negative 1. Negative 1 cubed is negative 1, right? That would be the point over here. And so this equation would be y plus 1, right? Because y minus negative 1 equals 3, and then x plus 1 as well. So we have 2 tangent lines to the graph of f of x equals x cubed that are parallel to this line because 2 tangent lines have a slope of 3, which is the slope of that line. So I hope that helps you out. Some good, fun problems starting to get in a little bit of the meat of calculus. And we'll talk to you soon.